Today we're going to continue with our study of numbers in expanded form. So we're going to jump right in here today by looking at the number 7234, 7,234. And you should be familiar with breaking that down into 7,000 plus 200 plus 30 plus 4. And we can see each of the numbers represented by their place value. And yesterday we talked about taking that one step further and recognizing that 7,000 is because we have a 7 in the thousands place. So we have 7 times 1,000 plus 2 times 100. The 2 times 100 gives us the 200, plus 3 times 10 will give us the 30, and the 4 is in the ones column, so it's 4 times 1. Now today, we're going to look at what is known as an exponent or a power. So I have a anchor chart that we're going to have a look at today, and this will be added to your math dictionary as well, so don't worry about copying it down. But what you can see here is we have the large circle just to show that we have the number 3 with a little 4 up here in the sky, and I've labeled the different parts of this to tell you that this whole entire thing is referred to as a power. And the number on the bottom, the large number here, is known as the base. And up here in the sky, we have what is called the exponent. And simply put, this one would be in long multiplication. If we were going to write it out the long way, you would have the number 3 written down 4 times and then multiplied all together. And that would be 3 times 3 is 9, that number, 9, multiplied by 3 gives you 27, multiply by 3 one more time, 23 by 7, and you end up with a product of 81. So rather than having to write it out, all 3 by 3 by 3 by 3, you simply just say 3 to the exponent 4, and you get a product of 81. So it helps with writing things down. It's another form of notation. What is nice about this is if the exponent was a large number, then you wouldn't want to have to copy down that base number over and over and over. So, for example, I'm going to go back to our earlier part of today, and I'm going to start with this one right here, the 2 times 100, and you can see that we're just using a number 100 right now, but we're talking about something called powers of 10. So we're going to write the base of 10. And if you had to think to yourself right now, if I had to take the number 10 and multiply, how many times would I multiply to get 100? And so I would take 10 times 10, which is 2 of them, and I would get 100. So I can put the exponent of a 2 up there. Again, I don't want 100, which is what the 10 to the 2 would give me. I need to multiply that 100 by 2 to get what I had above. So if we go backwards in our problem, and we also want the base of 10, 10 times 10 times 10, that's 3 of them, would give me 1,000, which is what the number is that I'm looking for above. And I'm going to ask for 7,000, not 1,000, so I still need to multiply through by the 7. You'll notice there is a pattern starting to develop here, that the exponent, which is the little number up in the sky, when the base is 10, there is a little trick, which is it matches the number of zeros in the answer. So you'll see the 2 is here in the sky as the exponent, and there are 2 zeros in 100. So using this pattern, we should be able to guess how many zeros are in 10. There's only one, so our exponent is 1. Now I'm just going to finish off this problem by showing you that there is a tricky rule here, and that is any base, in this case we happen to have the number 10, we've used the big 10 as all of our bases. When you have any base and the exponent, that's the little number up in the sky, when the little number up in the sky is a 0, it is equal to 1. And so we've made 10 to the 0, which is 1, and we've multiplied by 4, which gives us the 4 that we started with. So this part that I've just shown you here today is known as expanded form for powers of 10, or expanded form using powers of 10. We're going to just move our camera one little bit here, and we're going to refocus up here on this part of the board, just because we want to do a couple of examples together before you are off on your own. So we're going to look at the number 28,065, and I'm going to give you a few seconds to break that down in expanded form to show me that you know the different place values that make up that number. You can pause the camera now if you need to. Okay, so you should have written down 20,000, 8,000, 60, and 5. And you'll notice where the 0 is in the hundreds column, we didn't even include it in our number because adding 0 isn't going to change it. It would just take more writing. We're going to move on to the next step, which is taking 20,000 and recognizing that it is 2 times 10,000, and 8,000 is 8 times 1,000, and 60 is 6 times 10, and finally we have the number 5, which is 5 times 1. So if you need to pause the camera again, you may do so. I would now like you to turn these into expanded form using powers of 10, which are bases of 10 with little exponents. Pause. And so you should have ended up with 2 times 10, and we can do it the long way, which is 10 times 10 times 10 times 10, which gives us 10,000. Or we can simply use our trick that we learned earlier, which is counting the number of zeros, 1, 2, 3, 4. So we have a little exponent 4 up in the sky. We have to transfer down our addition symbol. 8 times 10 times 10 is 100, times 10 is 1,000, which is the number we're looking for. Or we can count 1, 2, 3 zeros up in the 1,000 and simply transfer a 3. Addition symbol gets transferred down. 6 times 10 to the 1 0, so we put an exponent of 1, plus 5 times 10, and we know that anything to the exponent 0 will give us a 1. So we're going to put the exponent of 0 here. And you end up with 2 times 10 to the exponent 4 plus 8 times 10 to the exponent 3 plus 6 times 10 to the exponent 1 plus 5 times 10 to the exponent 0. You'll notice they are in descending order, 4, 3, 1, and 0. We're missing the exponent of 2 because there is 10 times 10, which would be 100. There is no digit other than the 0 in the hundreds column. So it doesn't get accounted for in our answer. Thank you.